Hey, greetings people, hope you're all doing well. Today we will do a little experiment with a DC motor and we will measure physical parameters and we will run a simulation in MATLAB and we will compare the physical parameters with the virtual one and see the difference. Let's get started. For this experiment we need a DC motor. It doesn't matter which one is it. You can use this motor or you can use a smaller one. We need batteries. I will not use battery. I have a power supply, so I will use a DC power supply. We need an electric tape. We need breadboard, a cutter, and bunch of wires. So take the electric tape a little bit. Once you have a electric tape, stick it to the tip of the DC motor like this. So once you have this, the reason why we're doing this is to later on measure the speed of the motor with RPM, revolution per minute, or revolution per second, RPS. So we will connect this motor now to a power supply. I have a multimeter. I can directly connect the DC motor to 9 volt battery, as you can see, but this way it's really fast. I cannot measure it properly. So what I will do, I will use a smaller voltage with the help of my power supply, or you can use a DC battery, 1.5 volt. So now I will connect it. I will connect the other side to the multimeter. I will turn on my multimeter now to the voltage. Okay, and I will increase. I will now increase my voltage. The voltage is in 2 volts, as you can see. The current is 0.5. I will take it too much smaller. So I will now decrease the voltage more. What I will do now, I will take a marker, a permanent marker, and I will put a mark like so. Once I have this mark, I will connect it again. So now what will I do? I will record the video in a slow motion and measure the revolution per second of this DC motor and then multiply that by 60, which will give me RPM, revolution per minute. Now still this is very fast. I will decrease the voltage to 1.5. See, now it's 1.5. It's really slow. I can take just a camera or an iPhone camera and do slow motion with this and measure the revolution per second, and you can see the current is 0.05. So even from this video, if you see it, you can see that this revolution per second. Now to measure the resistance of motor, what I will do from multimeter, I will turn this from the 10 amp max to the micro amp in resistance port of multimeter. and bring this to 200. And measure. So as you can see, I get something around the resistance of the motor is around 6 ohms, 6.5 ohms. So I will take it as 6.5 ohms. So this is how you measure the resistance of a motor. So after I did the measurement and I did the slow motion counting of the motor and I measured the revolution per second, and then I multiply revolution per second by 60 to get the revolution per minute. So when I have 1 volt, my current will be 0.065. The resistance will be 6.5, which is constant. So these are physical parameters. So before going to MATLAB, we need to see something else too. So this is how the circuit will look. We have resistor, inductor in a motor, but actually the motor itself have its own resistance and inductance, but we will ignore that, especially the inductance part for the motor. And we have a voltage source. In this case, I have a power supply. For you can use a battery, and then we apply Kirchhoff's law, and this is the equation we get, which is this current multiplied by the resistance, and then the voltage equation for inductor, and the voltage equation for the motor. This is for the electrical system. Also, you can do the physical part, but when we do the simulation in MATLAB, we will need a step block for the we says for the voltage source. We need a step block. We need a sum block for the addition parts, and we need the gain part for the multiplication parts, and the integrator part. This is for the differential parts. So if you have a differential equation of second order, then you will use two integrator part. But in here we just have one, so one integrator is enough, and we will just at the end we will use scope for the graph or for the output of the system. So that's it for the physical system. Let's go to the virtual system. So now I open MATLAB and I'm using MATLAB online. So there is two ways of opening a component in MATLAB Simulink. One is to go to libraries, the other one is to just double click on the screen of MATLAB and open the search, and then search for the component you want to search for. So in this case I search for the step function, and next I will search for the sum or add component of Simulink. I will double click on it and I will change it to plus minus plus. You can change it to minus plus minus. It's up to you. And now I'm searching for the gain or the multiplication and differential equation. So this is the gain. So basically this is how our end result will look like. So as you can see, the MATLAB parameters will match the physical parameters. In 2 volts, the current is 0.1 amps and is perfectly matching our results. So Simulink is using a perfectly ideal world, but in real life there is friction, there is air resistance, so there will be difference a little bit in measurement. So thank you for watching the video. If you like this kind of content, please subscribe, hit the like button. It will motivate me to make more videos. Thank you.